Hello students, welcome to math tutorial. Today I have selected the topic derivative from class 12. The derivative is denoted by f dash x. We can also write dy by dx, and it is defined as limit h tends to 0 f of x plus h minus fx by h, where it is provided that the limit exists, and this method of calculating derivative is known as derivative by first principle or definition. So how to calculate derivative by first principle? Let's take an example. Suppose a function is given f of x equal to x square. Now by first principle we can write f dash x equal to limit h tends to 0 f of x plus h minus f of x by h. Putting their corresponding values, we get limit h tends to 0 f of x plus h. We are already given f of x equal to x square, so f of x plus h will be x plus h whole square minus f of x will be x square, and upon h. Simplifying it, we get limit h tends to 0 a plus b whole square we can apply here, so we get 2xh plus h square minus x square divided by h. X square and x square will be cancelled because of the opposite sign, and limit h tends to 0. Here h is common, so we get h into 2x plus h divided by h. H and h again cancelled. In place of h now we can substitute 0, and then we get 2x. So we can write f dash x is equal to 2x. This is the derivative of given function fx equal to x square by method of first principle. Similarly, let's take another example. F of x equal to e to the power root under x. Now again, according to first principle, we have derivative of f of x is limit h tends to 0 f of x plus h minus f of x by h. Putting their values, we get limit h tends to 0 e to the power root under x plus h minus e to the power root under x divided by h. Now after this, taking the help of y and y plus k, we can simplify it. Taking y equal to root under x and y plus k equal to root under x plus h, such that when h tends to 0, then we get k tends to 0, because if h is 0, then k will be root x minus again root x, k also 0. So we write, in this case, when h tends to 0, then k also tends to 0, and it gives us value of k root under x plus h minus root under x. This is the value of k. Now again we get f dash x equal to limit h tends to 0, putting the value of y and root under, putting the value of root x and root x plus h, we have y plus k minus e to the power y by h as it is. Here in place of this y, we are just putting the value of y which we have supposed in this step. Root under x equal to y, and this y plus k equal to root under x plus h. So here root under x plus h will be now y plus k. Now limit h tends to 0, y e to the power y into e to the power k minus e to the power y by h. Powers are added, so we can break in terms of multiplication of same base. Then limit h tends to 0, e to the power y is common, so we get e to the power k minus 1 by h into e to the power y. And we know we have h tends to 0, k tends to 0. So here we can write h and k both tends to 0, because e to the power k minus 1 by k will be 1, and here k tends to 0. It has come from h tends to 0. So we can write here h and k both tend to 0. And there, to balance this, we write k by h into e to the power y. Now we know this is 1, so there is no use of k tends to 0. We can write limit h tends to 0, value of k is root under x plus h minus root under x by h into e to the power y. Then rationalizing it, we have limit h tends to 0, x plus h minus x by root under x plus h plus root under x into e to the power y, and h is here, so we can write this here. X and x cancelled, again h will be cancelled. We can put this value, and then we get root under x plus 0, root under x e to the power y. Value of y is already root x, so this is our answer. Hope you understood it. Thank you.